Alright, y'all. So 8.3 deals with polynomial division. Alright, y'all. So the type of division we're going to be looking at today is synthetic division. So there's three things I can use synthetic division for in this section. So the first thing we're going to use synthetic division for is finding function values. So things like f of 4, f of 5, and that stuff, I can use synthetic division to find function values. So here's a little thing about that. We got what we call a remainder theorem. And it says that the remainder of synthetic division, so the remainder of synthetic division is equal to the function value for a certain number or for a given number. So when we're finding function values, we'll go through synthetic division and we're looking at the remainder. The remainder will equal the function value, which is the same as plugging that number into the function and doing your order of operations and stuff. So not bad. Second thing we'll use it for is determining if a number is a zero. Of a polynomial. Alrighty, so determining if a number is a zero of a polynomial. So if a number is a zero of a polynomial, then the remainder of doing synthetic division must be zero. Okay, so let me write that better. So it must be zero. So if I check a number and I get any number other than zero as the remainder, then it's not a zero of that polynomial, okay? It has to have a remainder of zero to be a zero. So the third thing we can use it for is finding the quotient and remainder. All right, so we won't get into this as much now, but later on we'll see how I can use the quotient and remainder to help me do problems, okay? All right, y'all, so on my first problem, I'm going to sort of write the steps out of synthetic division as we work a problem here. So we're going to use synthetic division to find the function values. All right, so they're giving us f of x equals x to the third minus 12x squared plus 47x minus 60. They want us to find f of 3, f of -4, and f of 5. So to find f of 3 in the past, we put a 3 in for the x's and did our order of operations until we got an answer. So we're going to do this using synthetic division. So over here, I'm going to write the steps as we go through it. So the first thing we're going to do, we're going to write the coefficients of the polynomial. So here's my polynomial. I'm going to write the coefficients. Now, y'all, since this starts with an x to the third, everything under the x to the third has to have a placeholder. So we got x to the third, x squared, x, and then the constant term at the end. Nothing's missing here, so I won't be using zeros. But if I was missing any of these terms, I would have to put a zero as a placeholder for it, okay? So let's write the coefficients out. We got a 1, -12, 47, and a -60. So you're going to write out the coefficients and then leave a little space in the middle. And under that, I'm going to draw a line and I'm going to box under the last number here. So draw the line with the box. So y'all, what's going to happen? The box is going to be the remainder. So whatever we put in this box will be our remainder, okay? Now, these three numbers are the numbers I'm going to find the value of. So I'm going to start with f at 3. So this is called C. And C for the first one will be 3. So put the number for C. That is being evaluated. So next time I'll use -4 for my C, and then finally I'll put a 5 in for my C. All right, so y'all, the thing we do, bring the first number down below the line. So the first number for me is 1, so I'm going to bring this number straight down under that line. Any numbers right in here under the line, those are going to be the coefficients of the new polynomial that you would have by dividing this out. So I brought the 1 down. So multiply the number under the line by C. So the number under the line is 1. I'm going to multiply by C, which is 3, and place in the second column. So we're going to place the number in second column. So 1 times 3 is 3. We're going to bring that 3 right there. So now you're going to add that second column. So add the column and put answer under the line. All right, so you're going to add a negative 12 and 3. That's going to give you a negative 9. All right, y'all. So at this point, this negative 9 below the line, we're going to multiply by 3 and get the next column. So at this point, we're going to repeat until done. All right, so any number under the line gets multiplied by C to get the next column. So this is a negative 9 times 3, which is negative 27. So now you're going to add this column and put that answer below the line. So 47 and negative 27 is 20. So now 20 is under the line. We're going to multiply by the C and put that in the next column. So 20 times 3 is 60. And negative 60 and 60 give me a remainder of 0. So what that means is f of 3 equals 0. That is the same answer that you would get if you put a 3 in for all the x's and figured that out. So synthetic division is an easier way sometimes of getting those function values. So y'all have a question on this yet? If not, we'll go in and find f of negative 4. So f of negative 4, we're going to write the same coefficients, 1, negative 12, 47, negative 60. It's going to start out just like this one. 1, negative 12, 47, negative 60. I'm going to draw my line, and I'm going to box under the last number. All right, so now we're finding the function value for a negative 4. So negative 4 is now our C. All right, so we wrote the coefficients, drew our line with the box. We got C now. So now, bring the first number down below the line. So this first number is going to always come down and be below your line for you, okay? All right, y'all, so here we go. Any number under the line gets multiplied by C to get the next column. So 1 times negative 4 is negative 4. Now you got a column. You're going to add that and bring that below the line. So negative 12 and negative 4 is negative 16. All righty. I got negative 16 times negative 4 is a positive 64. All right, y'all. So I'm going to add that 47 plus 64 gives me 111. 111 times negative 4 is a negative 444. And y'all, that negative 444 plus a negative 60 gives us a negative 504. So that means f of this negative 4 equals a negative 504. All right, y'all, then we had one more. We had to find f of 5. So the coefficients are the same. 1, negative 12, 47, negative 60. I'm going to draw my box. And this time we said C was a positive 5. Alrighty, y'all, so here we go. Bring the 1 down below the line. And then we're just going to start multiplying and add until we get our remainder. So 1 times 5 is 5. Negative 12 and 5 is negative 7. Negative 7 times 5 is a negative 35. 47, negative 35, give me 12. And then finally, 12 times 5 is 60. And y'all look at that. Negative 60 plus 60 gives me a remainder of 0. So that means f of 5 equals 0. All right, y'all, any questions on that? Yeah, so I'm not seeing nothing. So let's continue on. So our next example, we're going to use synthetic division to find the function value. All right, so that's the same thing we did on the first problem. On this one, they're giving me f of x equals x to the fourth minus x to the third minus 11x squared plus 35x minus 39. They want me to find f of a negative 5. All right, so first I always check and see if I got all my terms. I got an x4, I got the x3, I got the x squared, I got the x term, and I got the constant term. So I'm not missing any terms. So I'm going to write out all my coefficients. I got a 1. I got a negative 1 for the x cubed. I got negative 11 for the x squared. I got 35 for the x term. And I got negative 39 for the constant term. All right, I'm going to draw my box. My line with my box under the last number. All right, so since I'm finding a function value, f of negative 5 is my c. All right, y'all, so we're looking for whatever answers in that box. So remember, my first step, bring the 1 down below the line. And then we're going to multiply, add until we're done, okay? So 1 times negative 5 is negative 5. Negative 1 plus negative 5 is negative 6. All right, negative 6 times negative 5 is a positive 30. Negative 11 and 30 give us 19. All right, 19 times that negative 5 is a negative 95. All right, y'all. So I got a 35 and negative 95. That's a negative 60. All right, so let's see what we got. Negative 60 times negative 5 is a positive, what, 300? And adding that gives me 261. So that means f of negative 5 equals 261. So y'all, let me show you on the calculator. You're going to get the same thing if you actually punch them numbers in. So I had x to the fourth, so that would be negative 5 to the fourth minus negative 5 to the third minus 11 times -5 squared plus 35 times -5 minus 39. So y'all, when I hit enter, I get 261, which is the same thing we just got on our synthetic division. So that's the trick on these, okay? Put your coefficients, bring down your first number, and then you're just multiplying, adding, until you get to that remainder, okay? All right, now we're going to use synthetic division to determine if numbers are zeros. So use synthetic division to determine whether the numbers are zeros. Of the polynomial. All righty, y'all. So let's see. They're wanting me to check -3 and 2, and f of x equals 2x to the third plus 3x squared minus 3x plus 18. So they're giving me these two numbers to check. I'm going to check -3, then I'll check 2. So y'all listen, on these problems, if the number is going to be a 0, then that remainder has to be 0 on these, okay? So let's see, we got an x3, x squared, x in a constant term, so nothing's missing. So I got a 2, 3, -3, and an 18. I'm going to draw my box. Over here, my first C is going to be -3. And then we'll do that over here with a 2, okay? All right, y'all, so guess what? First number comes straight down below the line. Then I'm going to multiply to get the next column. So 2 times -3 is -6. 3 plus -6 is -3. All right, then we're going to multiply again. -3 times -3 is a +9. All right, let's add this. -3 and 9 is 6. And y'all, 6 times -3 is a -18. And look at that. 18, -18 give me a remainder of 0. So since we got a 0 remainder, that means yes, -3 is a 0. Okay? So we're going to check 2 now. So my coefficients are the same. 2, 3, -3, 18. All right, y'all, this time you're checking a +2. All right, y'all, so let me give y'all a minute or two. One of y'all run this synthetic division and tell me, is 2 a 0 or not? If 2 is not a 0, then give me your remainder, okay? So y'all, I'm just going to let y'all run that in 2. All right, Ben, that was quick. Y'all saying no. Y'all are getting a remainder of 40. So let me check y'all and see. So y'all brought the 2 down. 2 times 2 was 4. 3 plus 4 gave y'all 7. 7 times 2 gave us what? 14. 14 and negative 3. Give me 11. 11 times 2 is 22. Boy, y'all are good today because 22 and 18 give me 40. Good job, y'all. So this one is no, since our remainder is 40. Good job, y'all. All right, so let's do another one of those, and they'll have 2 numbers they're giving us. All right, determine if the numbers are zeros of the function. All right, y'all, this time we're going to check negative 2 and 1, and they're giving us h of x equals x to the 4th plus 2x cubed plus 3x squared minus 5x minus 1. All right, so let's see. We got our x4, x3, x2, x, constant terms, so nothing's missing. So, y'all, that's a 1, 2, 3, negative 5, negative 1. All right, y'all. So, y'all, tell me, is negative 2 a zero of that polynomial? All right, so y'all are saying no. All right, good job. So let's check. So we brought a 1 down. 1 times negative 2 was negative 2. 2 and negative 2 gave me a 0. 0 times negative 2 is 0. 3 plus 0 was 3. 3 times negative 2 was negative 6. Negative 5 and negative 6 is negative 11. So let's see. Negative 11 times negative 2 is a positive 22 and negative 1. So we get a remainder of 21. So this is definitely no. All right, y'all. Well, how about 1? So we still got 1, 2, 3, negative 5, negative 1. So is 1 a 0? And Ben, you done got a yes up there. So let's go. So bring the 1 down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 3 plus 3 is 6. 6 times 1 is 6. Negative 5 and 6 is 1. Good job, Ben, because 1 times 1 is 1. Added the negative 1, gave me a 0. So good job. So y'all, really, this synthetic division is not bad. Um, Once you follow them steps, you're good to go. So y'all, let me throw a tricky one on you. This is the last one for this section, okay? Let's see what we do here. All right, so we're going to use synthetic division. to determine if a negative 3 halves is a zero of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2. So I'm throwing fractions at you, but look, be happy that they all got the same denominator, okay? So we won't have to go through and try to find common denominators as much as we would if these would have all been different, okay? All right, y'all, we got the x3 term, the x squared, the x, and the constant term. So let's write out our numbers. 1, 1/2, 5/2, and then a negative 3/2. So those are my four numbers. I'm going to draw my line in my box for my remainder. And C was the negative 3/2. All right, so we're looking for a zero to be a zero. Any other number, we're putting no. All right, y'all, so bring that 1 down below that line. All right, 1 times negative 3/2 is a negative 3/2. All right, y'all, so here you're adding, you got a common denominator. So you basically got 1/2 minus 3/2, which will equal a negative 2 on top over the denominator 2. And y'all look at that. Negative 2 divided by 2 makes that a negative 1. All righty. Now you can add these on your calculator if you want to. It'll add fractions. So here we got a negative 1 times a negative 3/2. That's going to make that a positive 3/2. So now I'm adding a 5/2 plus 3/2. Well, 5 plus 3 is 8 over 2. And y'all look at that. 8 divided by 2 equals 4. All right, y'all. So now I got this 4 times this negative 3/2. So negative 3/2 times 4. I'm going to put the 4 over 1. So that's going to give me a negative 12 over 2. So I'm just going to bring that as a negative 12 over 2 since I got that fraction with the 2 under it. All right, y'all, so let's add that up. Negative 3/2 and you're minusing a 12/2. That's going to be like a negative 15/2. So that's not a zero. So this would be a no. So sometimes they make that one equal 0, sometimes it's not. So you just sort of got to play with that one, okay? Y'all, so any questions on those? That was 8-3. Hey, so y'all good on that one? No questions? Alrighty, y'all. So 8.4. If you're a little bit weak at foiling, you won't be after this section, okay? So this is 8.4, and it deals with theorems about zeros. Alrighty, y'all. So here we go. So this first problem wants me to find a polynomial function of degree 3 with real coefficients that has the given zeros of -3, 4, and -5. So they're saying these are your three zeros, which means these are the three solutions to this polynomial. Now I got to end up with a degree 3. So when I'm done, the largest exponent has to be a 3, okay? Well, that's true because you got three zeros. You're going to end up with a degree 3, okay? So what we're going to do on these, we're going to work in reverse to get this polynomial. It is exactly opposite from factoring and solving the polynomial, okay? So we're going in the other direction. So if these are the zeros, that means that these are the solutions of this polynomial. So since they're the solutions, that means x equals -3, x equals 4, and x equals a -5. Now, we're going to go in reverse. So to go in reverse, we need a 0 on the right side of all these answers. So the first thing we need to do, we need to get a 0 on the right side of the equals. Well, if I'm going to get a 0, I'm going to add 3 to this side, which means I'm going to add 3 to the other side. So that'll give me an x plus 3 equals, well, -3 and 3 is 0. So we're going to do the same thing. Subtract 4 from the second one. I get x minus 4 equals 0. And on the last one, since that's -5, I'm going to add 5 to both sides. And that's going to give me an x plus 5 equals 0. Alrighty, continuing in reverse, I got three factors that are equal to 0. So at this point, I can multiply all these together, and I'm still going to set it equal to 0. Alrighty, so they're all in parentheses. So now, to come up with my polynomial, all these have to be multiplied. So y'all, I'm going to start with these two first. I'm going to FOIL these two together. So I'm going to bring down the x plus 3. And when I FOIL these, I'll put that answer here. So I'm going to FOIL on the side here. X minus 4 times x plus 5. Once I get that answer, I'm putting it right here, okay? So x times x is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Now you add the like terms in the middle, so I end up with an x squared. 5 and negative 4 leave me 1x, and then my minus 20. So y'all, that goes here. Now, I'm going to, it's not really FOIL, but we're going to multiply all of this. But you're going to do it like you're going to FOIL. You're going to take that x, and we're going to multiply by all three of those. Then we'll take that 3, multiply by all three of those, okay? So since this is the last thing I got to multiply, I'm just going to do it right here instead of on the side. So y'all, x times x squared is an x cubed. X times x is an x squared. X times negative 20 is a negative 20x. Now, 3 times x squared is a 3x squared. 3 times x is a 3x. 3 times negative 20 is a negative 60. So, could we go further on that one? Oh, yeah, good job, Olivia, because we got like terms here and here, and then like terms here and here. So I can add the x squares together and then the x's, okay? So I'm going to bring down my x to the third. So on the x squareds, I got 1 and 3, which will give me 4x squareds. On the x's, I got a negative 20, positive 3. So negative 20, positive 3 will give me negative 17x. And y'all, at the end is my negative 60. Now, on the answer blank, they got this. F of x equals x3 plus blank x squared minus 17x minus 60. So y'all, that's what they got in the answer blanks. All we got to do is figure out what went into that box. And I'm sort of happy when I seen that because all their other numbers are matching up. So all they want me to put in the box is whatever number's in front of that x squared, which would have been R4. So y'all, 8.4 is heavy on the fooling in the beginning, okay? Now this one was fooling 3 integers. So y'all, let me show y'all what's coming up. So write a polynomial in standard form whose zeros include 2, 6i, and a negative 6i. So y'all, on this one, they didn't tell me what degree I'll end up with, but I got 3 zeros here. So that means we will end up with an x to the third as the largest exponent, okay? So the largest exponent equals how many zeros you got? Now, in this section, we got to recall I squared equals -1. Anytime you get an I squared, we will replace it with a -1, okay? Because remember, I is the square root of -1. So a square root of -1 times the square root of -1, we get a -1. So just remember this. All right, y'all. So here's my three zeros. Let's write that out. We got x equals 2, x equals 6i, x equals a -6i. So that means these two are imaginary since they got that I on them, okay? But I'm going to work it the same way. I need to get a 0 on the right side. So for the first one, I'm going to subtract 2 from both sides. I get x minus 2 equals 0. Right here, I'm going to subtract 6i. I get x minus 6i equals 0. And then the last one, I'm going to add 6i. So that I get x plus 6i equals 0. Alrighty. Got three equations equal to 0. We're going to put them in parentheses and set this whole thing equal to 0. Now, that last problem, we wouldn't have been picky which two things we foiled the first. But y'all, when you got imaginary factors like this, you want to definitely multiply these factors together first. So on the side, I'm going to multiply x minus 6i times x plus 6i. So y'all let me do some explaining on these. X minus 6i, x plus 6i, these are what we call conjugate pairs. Conjugate pairs look exactly the same other than one's being subtracted, one's being added. Now the nice thing about conjugate pairs when you multiply imaginary stuff, if it's conjugate pairs, the imaginary I goes away when you FOIL this. So when I'm done, I will not have any more I's in my problem, okay? And then I'll bring it over here and replace that. So this x minus 2 is coming down for the moment. And we're going to multiply by whatever this gives us. So y'all, let's FOIL this. X times x is x squared. X times 6i is a positive 6i x. Now I'm going to do the negative 6i times that x. I get negative 6i x. And y'all, a negative 6i times a positive 6i is a negative 36i squared. All right, y'all. So what happens to this? You got a 6ix and a negative 6ix right there in the middle. Those are going to cancel each other out. Because positive 6i, negative 6i equals a big 0. What did we say I squared equaled? It equals -1. So you're technically going to replace that I squared with a -1 and multiply by that negative 36. So I'm going to bring down my x squared. This negative 36 times that -1 is going to make that a positive 36. And y'all look, the I's are gone. Okay? Now, anytime you FOIL conjugate pairs of imaginary numbers, it will end up positive, okay? All right, y'all, so that x squared plus 36 is going into parentheses. All righty, here you got two things times two things. So we're going to FOIL this. And I'll just FOIL that right here. So here we go. X times x squared is an x cubed. X times 36 is a positive 36x. On the inside, negative 2 times x squared is a negative 2x squared. And y'all finally, negative 2 times 36 is a negative 72. Now for their answer, they had f of x equals x cubed plus blank x squared. Whoops, they got minus, my bad. I was looking at the wrong problem. They got an x cubed minus blank x squared plus blank x minus blank. So this one, they had three boxes we had to fill in. So let me get this in order first. So my x cubed. Then I want to put my negative 2x squared. My plus 36x. And then minus 72. So see, I got my minus, plus, and minus like they got them now. So I need a 2 here. I need a 36 for my x, and then minus my 72. So a lot of the answers in these first two or three, they're going to give you most of the answer, and you just fill in what's left, okay? Y'all got any questions on those yet? All right, y'all, so what we're going to do, it's almost 11, so let's take a break, and we'll come back at 11:05. And then share my screen. All right, y'all, so the next example. Find a polynomial, lowest degree. With zeros of. All right, y'all, so on this one, they got square root of 6, negative square root of 6, and 5. So they're not telling me the degree on this one, but I got 3 zeros. So that means we're going to end up with a degree 3 again, okay? Now, for this section, you got to recall that the square root times itself equals what was under that square root. So like a square root of 2 times the square root of 2 would be a square root of 4, which equals 2. So a radical times itself equals the number that was under that radical, okay? So that's good to recall on these. So When I put these down, I'm going to put the 5 first because I'm going to multiply these radicals first on this one, okay? So x equals square root of 6. X equals a negative square root of 6. Same thing, we want a 0 on the right side. So I'm going to subtract 5 from the first one. Subtract a square root of 6 on the second one. And then finally, add the square root of 6 to the third equation. Alrighty, so now 3 equations equal to 0. We're going to put them in parentheses and set the whole thing equal to 0. So when you got radicals, you want to FOIL them first. Okay, so always start out with the radicals just like you did with the imaginary numbers a while ago. So I'm going to bring down to x minus 5. And I'll multiply by whatever we get here when we do our side work. So we're going to do an x minus square root of 6 times an x plus square root of 6. Y'all, these are conjugate pairs. So the radicals always give you conjugate pairs, just like the imaginary. Now, the nice thing about multiplying conjugate pairs of radicals is the radicals will disappear. Okay? So when I'm done, there will be no more radicals in this. So y'all, let me show you how that happens. X times x is x squared. X times the square root of 6 is the square root of 6 times x. All right, here you got a negative square root of 6 times x. That's going to equal negative square root of 6 times x. And y'all look here. A negative square root of 6 times a positive square root of 6 is a negative 6. That goes back to this property. Square root times itself equals a number under a radical. So a square root of 6 times a square root of 6 equal to 6. Now notice here, plus square root of 6, negative square root of 6, those are going to cancel. So I end up with an x squared minus 6. Now you could have did square root of 6 times square root of 6 would be a square root of 36. But y'all, the square root of 36 is still 6. So just remember that little property there, okay? Now, when you FOIL conjugate pairs of radicals, they always end up minus. So that I stuff ended up positive, the radicals will always end up negative. All right, y'all, so I'm going to put that here, x squared minus 6. So now 2 things times 2. We can FOIL this and be done. So x times x squared is an x cubed. X times negative 6 is a negative 6x. Negative 5 times x squared is a negative 5x squared. And then negative 5 times negative 6 is a positive 30. And y'all, the only thing I'm going to do to this is rearrange it to get it in descending order. So my x third minus my 5x squared minus my 6x plus my 30. Then on that one, Math Lab was pretty much A, B, C, D. So you wanted the one that had f of x equal this. Okay? Alrighty, y'all. So any questions on those first three problems where we had to do a lot of foiling? Alrighty, y'all. So let's start playing with these things now. So we got properties about zeros. So the first property, radical zeros always come in conjugate pairs. So radical zeros always come in conjugate pairs. That means if a square root of 5 is a zero, then negative square root of 5 is also a zero. Okay, so square root of 5, negative square root of 5. If they were written like this, if 3 plus square root of 2 is a zero, then 3 minus square root of 2 is also a zero. So I want you to notice when it's written like this, the only sign that's changing is in front of the radical, not the numbers in the front, only the radicals. And that's because of that quadratic formula. Maybe you had the plus or minus in front of the radicals. So radical zeros always come in conjugate pairs. So imaginary zeros always come in conjugate pairs. Remember, imaginary stuff comes from square roots of negative numbers. So you're still dealing with square roots in a way. So that's why these will always come in conjugate pairs. So if 2y is a zero, then negative 2y is also a zero. All right, 2y negative 2y. If it's written as a complex number, something like this, if 5 minus 7i is a zero, then 5 plus 7i is also a zero. Okay, so once again, the only thing that changes is the sign of the imaginary part. The number in front stays the same, okay? So knowing that, let's see what we answer on this question. Suppose a degree 4 polynomial. So since it's a degree 4, that means it has to have 4 zeros. So it says, suppose a 4 has the given zeros of negative 3, square root of 3, and 14/5. They want to know, find the other zero. So y'all, if I had a degree 4 polynomial that had 3 zeros of the 4 that were negative 3, square root of 3, and 14/5, what would the other zero be? So the other zero is blank. So using what we just learned here, what would the under zero be here? All right, so you're going to go through this. We didn't say nothing about negative numbers, but oh, y'all, look, here's a radical, and it's a square root of 3. And we said up here, radical zeros always come in conjugate pairs. So if square root of 3 is a 0, then that means a negative square root of 3 also has to be a 0. So on that one, you're just going by what they're giving you. And just remember, radicals always come in conjugate pairs. All right, suppose degree 4 polynomial has given zeros of I and 4 minus square root of 11. So they're giving me 2 zeros out of the 4. Find the other zeros. See, all the other zeros are blank. All righty, so they gave me 2 out of a possible 4 zeros. So I'm looking at what they gave me. Oh, they gave me an imaginary I. Well, we said up here, they come in conjugate pairs. So the conjugate of a positive I would be a negative I. So negative I is one of them. So then I'm looking at this 4 minus square root of 11. It looks like this type of stuff. It's a radical. And we said they came in conjugate pairs. So remember, you don't change the sign of the 4. Bring the 4 down. And since this was minus square root of 11, this will be plus square root of 11. And y'all, that's all you're doing in this section is finding the conjugate pairs of the zeros they're giving you. All right, so one more of those. So same thing, suppose degree 4 polynomial has given zeros of 1 plus 4i and 2 plus the square root of 3. Find the other zeros. So the other zeros are blank. All right, so you got one imaginary, you got one radical, so they both have conjugates. So instead of 1 plus 4i, the other zero would be 1 minus 4i. And instead of 2 plus square root of 3, the other zero would be 2 minus square root of 3. So anytime you got one, you got to have the other. They both got to be zeros of that polynomial, okay? All right, so the reason they were teaching us this was so you can do problems like we're about to do here. All righty, so here we go. We're going to find a polynomial of lowest degree. So they're not telling you the degree because they don't want to give it away. Find a polynomial of lowest degree that has the given numbers as sum of its zeros. All right, so they're giving me negative 2y and 7. So you're finding a polynomial, so it's like the first three problems I did where you're going to do all the foiling. But y'all, here's the question. They give me these two zeros. What else has to be a zero of that polynomial? Let's see if y'all can figure that out. All right, so we got a negative 2y and a 7. Well, y'all went silent on me. All right, y'all. So here's the thing on this one. Since they gave me these two zeros, that means 2i must also be a zero. So that means we're going to have x equals 7, x equals negative 2y, and x equals a positive 2y. So if they give you imaginary, you got to automatically assume that its conjugate is also a zero, okay? All right, so this will be just like problem 2. I'm going to get a 0 on the right side by subtracting 7 from the first one. I'll add 2i to the second one. And then I'll subtract 2i from my last one. All right, three equations equal to 0. I'm going to put them all in parentheses and set it all equal to 0. And y'all, we're going to start foiling. So I'm going to start foiling with my imaginary stuff first. So that'll be the first thing I foil on the side. X plus 2y, x minus 2y. Now remember, since these are conjugates, the I is about to go away. So y'all, here we go. X times x is x squared. X times negative 2y is a negative 2ix. 2y times x is a positive 2ix. And y'all, 2y times negative 2y is a negative 4i squared. All right, so you notice the middle cancels again. And y'all, that middle is going to cancel every time, okay? And once again, I squared equals negative 1. So we're replacing the I squared with a negative 1. So this is going to end up at x squared. Negative 4 times negative 1 makes that a positive 4. Remember, we said they always come up positive on the imaginary. All right, y'all, so filling that in, I got my x minus 7 times my x squared plus 4. All right, so 2 things times 2. I'm going to FOIL that and be done. X times x squared is an x cubed. X times 4 is a 4x. Negative 7 times x squared is a negative 7x squared. Negative 7 times 4 is a negative 28. And you'll notice the only thing I can do with this is rearrange it. So I get x to the third minus 7x squared plus my 4x minus my 28. Okay, so in Math Lab, they'll have the f of x. All you're doing is putting in your polynomial. All right, y'all. So the next one has the same type thing going on. So let's see what they're doing on it. So find the polynomial of lowest degree. Um, with the given zeros of square root of 3 and 5i. So they're saying lowest degree again. They're not giving it away. And y'all are giving me these two zeros. So that means negative square root of 3 and a negative 5i must also be zeros. So these always come in conjugate pairs. So I got 1, 2, 3, 4 zeros altogether. So we're going to end up with an x to the fourth on this one, okay? And y'all, I'm just going to put things together. X equals a square root of 3. X equals a negative square root of 3. X equals 5i. X equals a negative 5i. All right, so that's what they're wanting you to know on these two problems, the one before this one and this one. That if they're giving you these type of zeros, their conjugates must also be a zero, okay? All right, so we're doing this like we did the last one. I need a zero on the right side. So subtract square root of 3. I get x minus square root of 3 equals 0. Add a square root of 3. You're going to get x plus square root of 3 equals 0. Subtract 5i. X minus 5i equals 0. And you'll finally add 5i and get x plus 5i equals 0. All right, put everything in parentheses and set that whole thing equal to 0. So what I'll do, I'll FOIL the first two together and I'll FOIL the last two together. Now, since we foiled these enough and y'all seen that the stuff in the middle is going to cancel, I'm going to do what I call shortcut foiling on these. Since the middle cancels on these, we can do x times x and get an x squared. And then we can do the square root of 3 times the square root of 3. So that's a negative square root of 3 times a positive square root of 3. That's going to equal a negative 3. Remember, square root of 3 times square root of 3 equals 3. And the radicals always end up being subtracted. Now let's do that over here. X times x is x squared. then the negative 5i times 5i is a negative 25i squared. But remember, I squared equals negative 1. So that gives you negative 25 times negative 1, which is a positive 25. So that's how you shortcut the first two and then the last two. The first two, then the last two. Remember, imaginary always ends up positive, radicals always end up negative. All right, you got two things times two. So now we can FOIL that and get our final answer. So y'all, x squared times x squared is an x to the fourth. X squared times 25 is 25x squared. Negative 3 times x squared is a negative 3x squared. And then that negative 3 times 25 is a negative 75. Oh, look here, I got like terms on this one. So I'm going to bring down my x to the fourth. 25 and negative 3 give me a positive 22x squared minus my 75. So y'all, on that method, will give you the f of x, and you just put in x4 plus 22x squared minus 75. Okay, any questions on that problem? All righty, so y'all, let's continue. All right, y'all, so the last three problems, they're going to give us zeros and we're going to find the rest of them. So this is where we're going to bring our synthetic division back in the game. So it says the polynomial f of x has the given zero. Then it says find the other zeros. Alrighty, so let's see. They're giving me f of x equals x to the third plus 6x squared minus 2x minus 12. And then a semicolon, negative 6. So that means negative 6 is the first zero they're giving me. They want me to find all the zeros out of this polynomial. Now, this is the x to the third. That means altogether there's 3 zeros. They're giving me 1, so I got to find the other 2, okay? So what we do, we're going to do synthetic division and divide this 0 out of it. So my first C that I do is negative 6. And y'all, my coefficients, x3, x squared, x, constant term. So nothing's missing. So I got a 1, 6, negative 2, and a negative 12. So I'm going to leave space and draw my line and my remainder. So on this problem, I get to explain what that quotient stuff is. Y'all, let me ask you this. If this negative 6 is going to be a 0 of that polynomial, what does this remainder have to be? So remember in 8.3, if it was a zero of the polynomial, then the remainder had to be what? Good job, Ben. It's got to be zero. Now, since they're giving me this as a zero, we better get a zero here, okay? All right, y'all, here we go. Bring the 1 down. 1 times -6 is -6. 6 and -6 give me 0. 0 times -6 is 0. -2 plus 0 is -2. And y'all, -2 times -6 is a +12. And -12 and 12 give me a remainder of 0. But we knew that. So y'all, let me tell you what this means. Since this started out as the x to the third, these coefficients will start out 1 degree less. So this would be an x squared, an x, and a constant term. So this is like 1x squared, 0 x's, I don't have to write, minus 2. So that's what these numbers are. These are your quotient. These are the coefficients of the new polynomial. I'm just not putting a 0x in the middle because that's irrelevant. So what we would do at this point, once you get it down to an x squared, you can set this thing equal to 0 and solve for the last two zeros doing the quadratic stuff. So remember, anytime I had an x squared and a number, I put the number on the other side and did square roots to get my two answers, okay? So we're going to solve for the remaining two zeros. Okay? Now, I'm going to solve this by adding 2. So y'all, I'm going to get x squared equals that +2. I'm going to do the square root of both sides. So that's going to give me an x equals a plus or minus. And y'all, I can't take the square root of 2, so I'm going to leave that square root of 2. So on this one, the other zeros are so you can do a plus or minus square root of 2, or you can do a square root of 2, negative square root of 2. And that just proves our point that radicals come in conjugate pairs, okay? That's how you get them conjugate pairs, is by taking the square roots of a radical. All right, y'all, so that gave me an x3. I had to find the other two. They had already gave me this one. So let's see what we do on this one. For the polynomial, 1 0 is given. Find the other zeros. All right, y'all, so this one they're giving me p of x equals x to the 4th plus 55x squared minus 576 semicolon. They're telling me 8i is a 0. So 8i is a 0, so that's the one I'm going to start with. So we're going to start with 8i. Now look here. I got an x4. I don't have an x cubed. I got an x squared. I don't have an x. And then I got my constant term number. So for the missing x cubed and the missing x, we need to add zeros on our coefficients. So I got 1x4, 0x cubed, 55x squared, 0x's, and then negative 576. You always got one more number here than your highest exponent. So if that's a 4, you need 5 numbers. All right, y'all, I'm going to draw my box. Now on this one, we know they gave me this 0, so I better get a 0 answer. So y'all, here we go. Bring the 1 down. 1 times 8i is 8i. 0 plus 8i is 8i. All right, 8i times 8i is 64i squared, but that I squared equals -1, so that's going to make that a negative 64. Y'all watch this. Let me clear this off. You see down here by the decimal, there's a little blue Y. So if you'll do 8 second decimal times 8 second decimal, 8i times 8i is negative 64. So that calculator can multiply them i's for you, okay? All right, y'all, negative 64 and 55 is a negative 9. Negative 9 times 8i is a negative 72i. 0 and negative 72i is a negative 72i. Negative 72i times 8i is a negative 576i squared. But once again, the I squared equals -1, and negative 576 times -1 makes that a positive 576, which gives me a remainder of 0. Alrighty, so remember, these are the coefficients. It starts 1 degree less than this x4. So that means this is 1x cubed plus 8i x squared minus 9x minus 72i. So you still got 4 numbers. It's not quadratic yet. So we're going to use these 4 numbers and do the synthetic division again, okay? So I got a 1, 8i, negative 9, negative 72i. So y'all, here's the question of the day. I need to figure out what number to try next. So do y'all have any guesses what my next number that I can try would be? Oh my God, you are perfect. It's a negative 8i. Good job, Olivia. Because remember, these come in conjugate pairs. So if 8i is a 0, negative 8i is also a 0, okay? All right, y'all. So here we go. Bring the 1 down. 1 times negative 8i is a negative 8i. 8i, negative 8i is 0. 0 times a negative 8i is 0. Negative 9 and 0 is negative 9. And y'all watch here. Negative 9 times negative 8i is a positive 72i. So good job, Olivia, because that gave me a remainder of 0. So they gave me 8i. I know negative 8i is 0. And y'all look here, we're down to three numbers. This is like an x squared, because remember, it's starting one less than this one, which was a cube. So this is 1x squared, 0x's minus 9. So since we're down to the x squared, we're going to set that equal to 0 and solve for my last two zeros. So I got x squared minus 9 equals 0. Anytime I got an x squared in a number, I'm going to add the number and do the square root. So I'm going to add 9 to both sides. That's going to give me x squared equals a positive 9. I'm going to do my square roots. So that's going to give me x equals a plus or minus. Oh, and this one has a square root, right? Square root of 9 would be 3. So the other zeros are blank. It's going to be that negative 8i, and then a 3 and a negative 3. So there's 3. They gave me 8i. That made all four zeros. Because remember, that was an x4. So you had to have four zeros altogether. Okay? Now, y'all, if you put this 8i in there, it marks it wrong because it don't want the one they already gave you. It only wants the zeros that were left, okay? Anyhow, so we got one more problem to go. So let me see this last one here. So they want me to find the rational zeros and then the other zeros um, of the polynomial. And the polynomial is f of x equals x to the third minus 91x plus 90. So I'm going to find it. Now, rational zeros are any of the zeros that I can express as a fraction. So it's any of the positive numbers, negative numbers, and fractions. The other zeros are going to be the radical zeros or the imaginary zeros. So if I get them type of zeros, they're going to be the other stuff, okay? So that'd be part A. And then they want me to factor into linear factors. So that means just put them in parentheses. Um, but I'll show you how to do that. So part A, we got to find the zeros. Now, you know what's sad is there's got to be 3 zeros on this, but they didn't give me any zeros to start with. So, y'all, I'm going to show you the easiest way to find zeros when they don't give you none, and that's to graph it. Because remember, the zeros are equal to the x-intercepts. So, y'all, I'm going to go to the calculator and graph this so that I can get an idea of finding at least one zero, okay? So let's go to our calculator. I'm going to go to y equals. And I'm going to put that in. I had an x to the third. Arrow down. Minus 91x plus 90. So I'm just looking for x-intercepts that happen off of this polynomial, okay? I need at least one x-intercept. So here we go. Let's graph it. All right, so I can see it looks like it's crossing it 3 times. But y'all, the easiest one looks like it's crossing right over 1 on the x-axis. So if I go to second table and go to that x value of 1, you see the x value of 1 has a y value of 0. That's what I was looking for, at least 1 0, okay? So I know that 1 is a 0. So when I do my synthetic division, I'm starting out with a 1, okay? So just graph it and find at least one point where it's crossing that x-axis. All right, y'all, so let's see. Ooh, I got the x3 term. I don't have my x squared term. I got the x and I got the constant term. So I'm going to have a 1 for the x3, 0 x squared, negative 91 for the x, and then a 90 for the constant term. Now, that's the x3. So I need 3 zeros altogether. So here's the first one we found. So we're hoping we get a 0 remainder, okay? All right, y'all. So bring down to 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 91 and 1 is negative 90. Times 1 is negative 90, which gives me a 0 remainder. So 1 is definitely a 0. So now these are 3 coefficients. So remember, since it started with an x3 on this one, that means I got 1x squared plus 1x minus 90. I'm going to set that equal to 0 and solve it. Now me, I'm going to factor that, but if you don't like factoring, you can always do the quadratic formula, okay? Hey, also watch this. Here we go. X squared is an x and an x. This last number is negative. So that means these factors will have unlike signs, no matter what. Now, I want factors of 90 that'll subtract and give me 1. So y'all find me factors of 90 that subtract to equal 1. And remember, I said you could do them factors on your calculator. So let me share my calculator. I can go to y equals and do 90 divided by x. Remember, whatever number you want factors of, divide that by x and then hit second graph for the table. So y'all, I don't want none of them negative numbers. And you can't multiply by 0, that gave you an error. All right, so you got 1 and 90, 2 and 45, 3 and 30. None of those subtract and give me a 1. 5 and 18, no. 6 and 15, no. 8, no, because that's a decimal. 9, oh, look at that. 9 and 10. 9 and 10, multiply to get 90. They subtract to give me a 1. So it's going to be 9 and 10. Now, the larger factor is 10. The larger factor has to have the same sign as the middle. So the 10 is positive and the 9 is negative. So y'all, 10 and negative 9 equal 1. 10 times negative 9 equal negative 90. At this point, set both them equal to 0 and solve. So it's a little more work when that middle number is not a 0, okay? Because if that was 0, I'd have done my square root stuff and been done. But that was an actual trinomial, so I had to factor that. And now to solve these, I subtract 10, and then here I'll add 9. So it'll say rational zeros. So this one, only rational zeros. Only rational zeros, and the zeros are blank. So we had a 1, we had a -10, and we had a 9. So these are all rational zeros. The only time you'll have other zeros is if it's a square root or a imaginary. So that was part A. And then part B, linear factors, they're going to have this. The factorization of f of x into linear factors is, and then blank. So y'all, what they mean by linear factors is putting them back into parentheses. So if your 0 is a 1, that means your linear factor would be x minus 1. Remember, the factors are always opposite signs than the zeros. This one, since it's a -10, would be x plus 10. And y'all, the last one, since that's a +9, would be x minus 9. And that's all they mean by linear factors. So here's your zeros, here's your factors. They just want y'all to realize that the factors and the zeros are always opposite in sign, okay? All righty, y'all. So any questions over today? All right, y'all. So let me stop my share. All right, I'm just making sure I got all of y'all here real quick.